Hi guys, it's Mrs. Jacqua. It's going to be a pretty short webinar. But let's go ahead and talk about the last week of class. Want to go fly a kite. Okay, so this is just pretty funny. It's a fake tan. Anyway. Okay, so the quarter ends May 21st and I will be closing out grades that day. So all late work, all anything's got to be done by then. Okay, what we want to do is want to go test how high your kite can fly. You can use the ones that are in the classroom. The ideal wind speed is 10 to 15 miles per hour. Ask a teacher to go out with you. Now the wind's probably going to be a little bit fickle, so if it's windy when you're walking into class, then make sure you go out and you fly that kite because May has dead times. Okay, also go measure the height of a building and you can make a clinometer or you could use the one that's in the classroom. They're mine though, so make sure that you are nice and don't destroy my stuff. Because some of it was birthday presents. Kites are birthday presents and Christmas presents for me, so don't destroy my stuff. Okay, and so this is how a clinometer works, is you're looking from, this is 90 degrees, this first line is 90 degrees, and then when you have the washer on a string, it's going to drop, and from 90 degrees down to wherever your string is, that's the angle of elevation. Okay, so just a reminder, these were last week's notes for your SOHCAHTOA. You're going to need that in order to figure out the height of your objects. If you have a kite, thing you want to make sure that you measure is from your eye down to your toes. So we're just pretending 5'7", right? And then we want to make sure you measure, or you look through the clinometer until you see the kite and get that angle of elevation. Okay, and then you're going to measure, use a string to measure it. Okay, so the next picture I have is kind of my expectations of a diagram to come through. All right, so if this was me flying a kite, and I forgot to draw a little eye right there, and I was 5'7", my eyes are 5'7", which they aren't, they've got to be like 5'4", because they got to be a little less than how tall I am. Then what I'm going to do is I'm going to create a right triangle from my eyeball. Okay, I'm going to use a clinometer to figure out that 41 degrees because I was flying my kite. And once I get my 41 degrees, what you want to do is you want to stop flying your kite. So don't wind up your string. Let the kite fall, or you have someone else help you get the kite down, and then you want to measure the string. Okay, so I pretended that mine was 87 feet. And I have measuring tape in the classroom, so make sure you use it. So I measured mine as 87 feet. Okay, so my 87 feet is a hypotenuse. And then the opposite is what I want to find out. So I'm going to look at my SOHCAHTOA. SO and TOA have my opposite, but SO is the one that has a hypotenuse in it. Okay, that means the sine of 41 equals opposite over 87. Plug this in your calculator, so let's go to calculator. Make sure your calculator is in degrees, and then you're going to type in sine. You can do 87 times sine and 41, and it gives you 57, and that means 57 feet. Okay, so 57 feet, then plus the height of your eyes on this person was 5'7", so that means your kite was 62 feet 7 inches in the sky. Cool. Do that for a building too, but the building you're actually going to know the adjacent, and we want to find the opposite. So that's going to be a TOA thing. But all the little videos I have in Schoology are going to show you how to work those problems as well. All right, guys, told you it was going to be short. TTFN.